So, as Emre said, I'm Dr. Catherine Ramsdale from PragmatIC. I'm the VP of Device at PragmatIC, and I'm going to talk to you a bit today about what PragmatIC's doing in the field of IoT and what we're working on now in developing electronics for a flexible world and embedding electronics in everyday objects. So, a brief history of the company. We were founded in 2010 as a spin-out from the University of Manchester, and we now have about 60 staff, all based in the UK, with about 30 people here in Cambridge on the Science Park and about 30 people in Sedgefield in the northeast. The staff here are primarily focused on design and test and business development product, and the staff in the northeast is where our manufacturing line is just been installed and where we're beginning to make circuits in our own facilities. A couple of strategic shareholders just to set the scene. Arm, I guess, needs no introduction in this environment of who Arm are, but Avery Dennison are one of our other strategic investors, and they are a Fortune 500 company and are the world's largest RFID inlay manufacturer and a leader in labelling and packaging. So PragmatIC's raison d'etre, what we're trying to do is put electronics into objects that you don't currently consider to have electronic footprint. So if you think through kind of how technology has evolved over time, and silicon technology primarily, that in computers, which you maybe buy 1 or 2 a year in this environment, these people, there are about 300 million chips sold into computing per annum, and those ICs are roughly $100 per IC. If you can reduce the cost of those ICs, or you're using fewer of them, then you can increase the volume. So if you look at tablets or smartwatches and phones and so forth, there may be 50 billion chips sold into that market per year, with $1 to $10 per IC, and maybe you bought 3 of those in the last 12 to 18 months, depending on exactly how much tech you're into. Now, we're not considering those markets for our applications. What we are primarily interested in is how we can address this right-hand picture on this screen, where performance isn't your primary driver, where what you're aiming for is a low-cost product which will allow you not just to enter into the smart devices and computer market, but to enter into fast-moving consumer goods. So if you want to put some kind of electronics and intelligence on shampoo bottles, milk cartons, loaves of bread, tins of beans, that kind of thing, you can't be operating in the $100, $1, even 10 cents is too much if you consider how much it costs for a loaf of bread or a pint of milk. So you've got to be in this less than 1 cent per IC if you're going to address that market and going to bring some intelligence onto packaging. So we're focused entirely on how do we do this for 1 cent or less, so that we can address these kind of markets. And performance is not the primary driver in that scenario. It's can you do the performance you need for the price point that is acceptable. So the version of that that I'm going to talk about today is our work on looking in NFC in that arena. It's becoming more and more ubiquitous. There will be, by next year, 3.5 billion NFC readers that people carry around with them on a daily basis in the form of their phone. And if you consider putting some kind of electronic tag on a consumer product, like a shampoo bottle, you can see then the consumer could potentially interact with that product with their phone and get some kind of brand engagement from the brand owner's perspective and some type of data from the user's perspective. So we see a lot of interest in that market. Brand owners in particular, they lose visibility of their customers because they are selling to the supermarket or they're selling to Amazon. And Amazon are the people and Tesco's are the people who get information about what you bought and who you are. And the brand owners lose that. So if they want to find out how people are using their products, they have to have a focus group, and that will have a certain demographic, and it will be a subset of the population. And if they want to have more involvement with all of their consumers, then they need to be able to contact them directly. So from the brand owner's perspective, if they can put some electronics on the packaging that you can engage with, then they can engage with you directly. They can engage with you in the store. They can also engage with you at home, maybe in use cases for recipe ideas, if it's on products, or I don't know, hair dye and how long you've got to leave the dye in for, or that kind of thing. And it allows them to build an understanding of who their consumers actually are. And then the trade-off is the benefit to the consumer there. So from a consumer's point of view, you can see how that might then lead to a product authentication. So if you scan it and it comes back with it takes you to an authentic a website for that product, for example, or it somehow authenticates that, yes, you really are buying a Gucci, I guess Gucci's probably not a good example, but you really are buying a Cravendale milk, or you really are buying, I don't know, Coca-Cola, any kind of product like that. You can kind of see how you might be able to use authentication there to and the security aspects associated with that. And also maybe you've got ratings for the product or reviews, and you've got information about the content or of the product or what you might use that product with. So if you're buying carrots, what else you might want to buy with the carrots. That kind of information might come to you that way, or alternatively, if you need it in a different language or a different format or audio. There are loads of ways you can imagine how that might interact with your phone to provide you with a better experience, and also provide the brand owner with a better way of engaging with their consumers. So we see a lot of traction in this space, both in NFC and in RFID in general. And I guess I'm just going to talk a little bit about what we're doing there and how we are the same and how we are not the same as the silicon industry. So the functionality that we're looking at for NFC is exactly the same functionality you look at NFC in a silicon product. You have got to meet exactly the same kind of standards, same levels, same encoding, all of those kind of things. You need a clock divider, counters, data, modulation, and send the information back to the reader. So our approach is the same as you would take in silicon. You have you're simulating, and maybe in Verilog, and showing that your circuit's going to do what you expect it to do. We have analog simulations in the same way we do in silicon. We design with the same intended mindset as silicon, using the same kind of flow, because we want to be sure that we're not being novel where we don't need to be novel, and we're using the tools and techniques that are already there where it's possible to use them. So where we're different, though, is that we're not doing it on silicon. So we have flexible substrate, which we build off the circuits on top of, and that has some advantages in the types of markets we're looking for. So that has an advantage in that most of the product types we're looking at, and most of the things I've mentioned, are not rigid. Their packaging is moving, the labels can move, and having something that doesn't bend in the form of a silicon chip is a possible failure mechanism. And if you can have something that is robust and shock resistant and conformal, then you're much more likely to have things not fail in the field due to breakages. So everything that we're building is on a plastic substrate and is flexible. And we're doing that in our production facilities, as I said, in the northeast. Our production line is another area where we would differ from silicon. The whole line, I was trying to work it out earlier, but I think probably if you flatten this room down, it would fit within this room reasonably comfortably. And the CapEx expenditure for that line is about 2 to 3 orders of magnitude cheaper than a silicon fab would be. And it has the capacity for billions of FlexICs per annum, depending on exactly the size. And the whole thing is or can be self-contained in its own clean environment, so that you could put it in a grey space in a warehouse or somewhere where the facilities aren't like mega clean like you would expect to see in a silicon fab. So I have a short video to show you of the inside of the factory. So this has been most of the work that we've done so far this year is moving our technology from the CPI facility where we've been using their kind of custom equipment that they use for lots of different companies. We developed our process and how are we going to make things, and we've then bought equipment ourselves so that we can use our own equipment to hone our process and refine it. there's only so much you can do in a shared facility. So this year we've spent a lot of time developing, bringing these tools in and installing them. So you can see there that it's not a flexible substrate, despite me talking about it. So what we've actually done is laminated the substrate to glass. The substrate's on glass, and we do that because, as I said, we don't want to be unnecessarily novel if we don't have to be. So industry tooling expects the substrate to be flat. So if you expect the substrate to be flat, we need to make the substrate flat for the purpose of making the circuits. So we use the substrate on glass, and then we build up off the substrate, and then we go along at the end and take it off again. But all of the tooling you see here is off-the-shelf tooling that you would buy from, you'd expect to buy in other manufacturers, which helps from a kind of maintenance point of view. It helps from a staffing point of view because people know how to use it. It helps from a kind of uptime point of view because it's equipment that you would typically find in manufacturing environments. So here you can see them taking the substrate back off the wafer so that you can then use it again, and you can reuse the glass and start all over again with the process. So when you've done all of that and got the circuit off, it's not the end of the story. Obviously, it doesn't give you the NFC or the RFID on its own. It has to be integrated with an antenna. So we haven't forgotten about that part of the process, although it's not the part that PragmatIC has as its main competency. But if you look at then what does that mean for a tag? What we're doing, the picture on the left, shows kind of how a silicon process would work. You take the chip off your IC off your silicon wafer, and you stick it. There's a pointer here somewhere, wasn't there? Yeah. This bit. Yeah. You stick the chip there, and then you've got to bridge the antenna across here. So there's a few processes involved in that assembly. You're aiming to get your silicon obviously as small as possible because silicon is expensive and you don't need a very big area to do the type of functionality for NFC. You're not talking about lots of transistors. In our case, our chip's much bigger, which is partly why the capex is cheaper, because we're not trying to do 7 nanometers. So it's sub-micron, but it's only slightly sub-micron. So the IC is bigger because the tooling doesn't do 7 nanometers. And as a result of that, and obviously the substrate cost is cheaper because it's a plastic substrate rather than silicon. And so because of that, we can afford to make the chip big enough to straddle the antenna, and it becomes a crossover on its own. And that simplifies the assembly cost of the tag. So it's not just that the IC is cheaper, the whole tag cost can be reduced that way. And then just instead of the marketing department image, is just a bit more of a description. So out of those things I've said, this is a test chip that we had earlier this year with a couple of test points and the antenna points that would then fit across the antenna. And then that'll shrink down. In fact, in some cases, we've already got it shrunk down to this IC size that we're aiming for. And then also the other part of that is the thickness, as I briefly touched on earlier. The typical silicon IC is about 120 microns thick. If you run your hand over that, you will know you've done it. Whereas our IC is more in the region of 10 microns thick, which you can't feel if you run your thumb over it. So from an aesthetic point of view, if you're going into a label, this is kind of important from a brand's position, is you don't want something protruding from the label on your curved surface. So our IC would slide in with the label, and you wouldn't notice it was there. So in order to be able to achieve those kind of things, we have some projects with companies that are working in that space. So we have the Nekomada project, which is a Horizon 2020 project, which is looking at customized conductive inks and flexible adhesives to support the high-speed integration of this type of electronics. So you'd feed all of the ingoing materials into some kind of pick-and-place machine or some kind of integration machine, and that would assemble the final tag. Nearly finished. And then that's, as I mentioned at the beginning, we're working closely with Avery Dennison, who are one of our investors, on RFID and smart labels. But we've also had quite a lot of interest in this from some other global players in this field, including SmartTrack, and we had a project with them an iMEC called Ping, which was about putting an RFID tag in every single playing card in a deck of cards. And Cartamundi, who are a very big card manufacturer, when they want to check, for example, if a child takes a mobile phone and touches the card, then maybe there's some interaction with the card they've bought and collected, and some Smurf does something, or, I don't know, Moshi Monster does something. And then also with Talking Things, who are also in doing a lot of work in RFID. And then, apart from RFID, there are other things you can do with this technology. And one of the things we've been working on recently with ARM and Emre and John and James is a project called Plastic Armpit, which has connotations on all sorts of levels. I know all those bits stand for different things depending on who you are. But that's aimed at looking at flexible neural networks and how they can be integrated in our technology, and how that could be then used potentially as a flexible e-nose for armpit malodor recognition. And you can see how that might extend into other sensing applications as well beyond armpit malodor. And that was kind of what I wanted to say about what PragmatIC's doing. Thank you very much for your attention.
So we can take a couple of questions, yes?
Yeah, so what are the lower limits of scaling? Because depending on the size of the curved surface, you might need to fold more or to bend more.
Yeah, so we can, a radius of curvature down to about 5 millimeters should be fine. You wouldn't want to crease it. Creasing it would be bad, but as long as you're just curving it, it should be right to that.
What kind of testing procedures do you have for outgoing products? Are you testing them beyond what they're expected to
So,
be folded in or bend?
At the moment, it's still kind of development work. So we haven't got products in the marketplace, but we have specs from certainly in the Necamard project. We've got specs of it needs to get to this radius of curvature, which is much bigger than 5 millimeters. But the intention would be to test down to levels beyond what the customer would require, in the same way that you would for, say, humidity testing or other lifetime testing, that you're testing it beyond what the end consumer would have. There's lots of work we need to do in that area, because obviously the line is brand new, so anything we've done in that area before, whilst indicative of how it's going to be, is not the same as doing it all in all new tools. So we've got to look into that further.
Yep. Can you actually share about the gate density you're achieving at the moment, or are you able to do that?
I can't off the top of my head, no. It's, as I said, we're not focused on shrinking too far. It needs to shrink in order to be the size we need for the tag, but an NFC chip has 1,000 gates or thereabouts in it, so that would have to fit in the space.
Yes.
So apart from applications where you use RFID or NFC
Yeah.
antennas, for example, the armpit sensor,
Yeah.
where do you plan to get your power from?
Oh, you could. So we have had projects in the past where the cost factor is lower, and maybe people are doing a promotion activity. So we had a project where we used a flexible battery in order to make lights on a beer bottle, light through a skull on the front of the beer bottle for a particular promotional activity for a Mardi Gras thing in, I think it was Mardi Gras in Cuba, or the launch of some product no, it was Brazil, but somewhere in South America as a product, and they wanted the lights to come through the eyes, and that used a flexible battery. So you could do that. Of course, flexible battery would then add to your cost structure. So, that kind of extra ecosystem needs to be looked at as to whether it makes sense, and whether it makes sense on all your packaging, or if you want to do one particular promotion for a particular event or a particular new launch of a product, then you might sustain a higher cost point for that particular thing, but obviously not if you're trying to get it in everything.
What's your timeline for mass production?
So the line in Sedgefield is operational, so it's now a question of just bedding everything in and finishing. So I think I'm not the best person to ask on that, but early next year we should, end of this quarter, we're in quarter 4 now, beginning of next quarter we should slowly start to ramp up.
One more question.
Yeah. Does the consumer have to be told that they're buying an electronic device in their bread or whatever? Because to
me, it seems like some consumers would not like that idea.
I can quite believe that. So I think I mean, I don't think we would start at bread for obviously, but you would have to. And I don't know what the regulatory aspects are, so I'm also not the person to ask about that particularly. But I would agree also from a consumer point of view that you'd expect to know that you can interact with the product. So how you're told that, I guess, would be a brand decision, but you'd expect to know that, right?
All right. Thank you, Catherine.
Thank you.